Yes, Abhishek, we
Yes,
are able
Abhishek.
to see your screen.
Okay. So hi all, and today I bring you one serverless session. So this would be for more of a theoretical concept. So like a lightweight session, but again it's pretty important. So don't worry about this term designing. I know when we become an expert, then we get into the designing stuff. So I'll be walking you through like what serverless is and what it means in the Azure world. Then only I'll get you into the designing thing. So let me start by introducing myself. I work as an architect in intelligent cloud and automation space on Azure, AWS, and GCP. I am a C# Corner MVP. I am a published author and I published a book on mastering Azure Serverless Computing with BPP Publications. I have reached 15 plus years of experience, out of which around 7 to 8 years I've spent in designing cloud-based architectures. So that was a short introduction on me. And today what we are expecting is like I'll start with what serverless on Azure is. I will explain you like what exactly the serverless thing is and how significant it is on Azure. And then we will get into the design considerations. So we'll see like what are the characteristics of serverless computing. And at the same time also we will take a look at like what are the basic design considerations we should take, because whenever we design anything, so it's very important to discuss on the considerations, right? Because they are one of the key inputs that will help us in getting our things right or our design right. So we'll be discussing on the design considerations. Another important point to it, it is definitely it's a part of the design considerations. But again, I just wanted to highlight it as a separate pointer because it's a very important thing. So like we have so many things in cloud-based technologies today, right? So we can build our application and host it on infrastructure as a service, platform as a service. We can do it on containers. We can do it on serverless. But when to do what? That is a very important question. When do we want to go for an infrastructure as a service, and when do I want to go for a platform as a service, whether like my application fits in for the serverless. So let's discuss, or we'll like spend some time in discussing all these concepts. I mean to say like how your application fits in, the fitment we'll discuss here actually. Then I will take an example of an e-commerce application and I will build a reference architecture for you and walk you through the reference architecture. So that is how the agenda is, and for the next 45 minutes to 1 hour will be on this. Okay. So let me start on serverless on Azure. So I can see like, okay, let me come back to the screen. I can see there are a lot of audience out here who have already hands-on in serverless. Who can tell me what serverless computing is?
Abhishek, can I?
Yes.
Yes, so serverless is not related to I mean, there is no server in that kind of way we can't describe. It's like we are actually deploying our code and we are giving we are actually paying the cost for our consumptions only.
Okay.
And then whenever the code will run, it will consume and we have to pay for it. After that, those servers will be allocated to other things as well.
Okay. Perfect. So that is one of the very important pillar of serverless computing. Anything more you would like to add, or someone would like to add? There is one more other characteristics that is also associated with serverless.
Abhishek, I would like to add up. It's more like an infrastructure abstraction model which allows you to pay for the consumption of services that you consume, that your application actually consumes.
Yeah, pretty much. Yes, that is what it is. Okay. Now let me tell you. So I'll come to the this left part. Like I'll talk about the evolution of the serverless applications. But before that, let me explain you what serverless is. We have already touched upon this thing like paper consumption. So let me explain this. Like then I'll come to the other 2 points. So when we build any kind of serverless applications, or like we consume any kind of serverless services, so what happens is we pay only when we consume it. Okay, we don't pay whenever the service is not running. Suppose, for example, I have hosted a piece of code on a Azure function, which is a serverless service. That service will not bill you, or you won't get any bills for using that service whenever that service is not getting invoked. Only when you invoke that service, you get a bill. Okay, so that is what your pay per consumption model is. Only when you are consuming the service or using the service, then only you pay for it. But you will now contest with me like, then what is platform as a service? In serverless, we do this. In case of platform as a service, what happens is you, as soon as you create the application, so for example, a app service, as soon as you create an app service, your billing starts, your clock starts for your billing, and you have to pay whether you are invoking or not. You have to pay for the underlying server, whether you are using it or not, unlike the serverless model. Okay. So, and when we call it a serverless, as rightly mentioned, there is nothing called a serverless. So actually what happens is the underlying platform is abstracted to us. And as a developer, what we do is we just build the application and host it. All the hosting environment setup, all the infrastructure related setup, the infrastructure maintenance, the operations, everything is taken care by the underlying platform provided by the cloud provider. So that is why we call it a serverless, because as a developer, I need not worry about the underlying servers or any of the infrastructures. I just need to like concentrate on building my application, bringing it in and hosting it on that service. That's it. So it's as simple as that. So as a developer, I just need to spin up that service, bring my code and host it, and need not worry about the underlying platform. That's why we follow this just build and host model. And this most important point in serverless is scale on demand. Okay. So if you have worked on platform as a service model, so any kind of web app, so we do a lot of auto scaling settings, right? So we take care of the scaling mechanism. So we define the scaling concepts and all, and we control how your application scales. I mean the parameters based on which your application scales. That means we can control the scalability factor of the application. But when you come to serverless, it scales on demand. The underlying platform will take care of the scaling aspect. What I mean by that, for example, on a Monday, you have an application on Monday, the scale would be less because there will be less number of incoming requests. Assume that on Friday, the request becomes 3 times. So what will happen is in this case, so whenever the request becomes 3 times, the underlying platform, what it will do is it will spin up multiple instances automatically uh, without your intervention, and it will start managing the incoming traffic or the incoming request. That is why we call it a scale on demand. And serverless, in the case of serverless applications, the scaling happens by default by the underlying platform. Whenever the underlying platform senses that or sees there is a surge in traffic, it will automatically scale the application, and you need not do any kind of scale settings for it or worry about the scaling aspects. Okay. So these are the 3 aspects to it, like pay per consumption, scale on demand, and just build and host. Whenever we have all these 3 pillars with us, then we call it as the serverless application, or like we are calling it as a serverless service. Okay. So now let me just briefly touch upon the evolution of this serverless service. So how it came up. Okay. So earlier we used to host everything on premises. Okay. We used to have the infrastructure. When I say infrastructure, like we used to build our own data centers. Inside the data centers, we used to like put our operating system. On top of the operating system, we used to have our hosting environment. On top of the hosting environment, then once our hosting environment is ready, then we used to do the scale settings and application deployment, of course, like application runs on top of this environment. So if I take an example of a .NET application, so you build the .NET application. So hosting environment will be your IIS. So you need to do all the IIS settings. You need to configure the scaling or the scaling mechanism you need to manage. And then you need to deploy your application. And all these are the responsibility of the developer. The developer does all these things. When we come to infrastructure as a service, so what happens is this infrastructure part is abstracted to the developer. So you need not worry about the infrastructure part. So what will happen is your cloud vendor will take care of the infrastructure. For example, like you are creating a virtual machine, that virtual machine infrastructure is managed and handled by the cloud vendor. You don't have a control over the infrastructure. And operating system, definitely you can call it out, like whether you want a Linux based operating system or a Windows based operating system. And with that, your VM will be ready. But again, you have some duty towards the operating system. So you need to patch the operating system. You need to see that all the vulnerability remediations are done. So all these things you have to take care at this level. Then you need to have the hosting environment ready. So when I say the hosting environment ready, like you need to have the IaaS ready. Then again, the scaling you need to take care of, and again, the application deployment. Okay. Now, with this, so what you are saved off is the infrastructure. You need not worry about the infrastructure when you are going for infrastructure as a service. But the challenge with infrastructure as a service is cost. It is costly because you are reserving a virtual machine. You are reserving a hardware. I mean, it's a piece of the hardware because that virtual machine is anyways like you'll have multiple virtual machines running on a data center. But anyways, you are reserving some kind of compute capacity or the virtual machine. But the advantage at the same time is like you have a control over that virtual machine. So you can get into the virtual machine, you can tweak your virtual machine, and this environment is very much near real time to what you have in on premises, except that you don't have the control over the hardware. Here actually you are doing everything on a physical server, and you are doing the things in the virtual machine in case of infrastructure as a service. So you own the environment and the virtual machine as well. You have access to the virtual machine and you have full control over the virtual machine. So that is what infrastructure as a service is. Then we have another model that is called as platform as a service. Here what happens is the infrastructure part is managed by the cloud vendor. The cloud vendor manages the operating system as well as the hosting environment. That is, you don't have a control over the operating system, maybe Linux or Windows, the infrastructure, as well as the IaaS environment or the hosting environment. Maybe like in case of .NET, we use IaaS. In case of Java, you can use Tomcat. Like you can have even different kind of hosting environments or hosting servers, right? So all these hosting environments, OS and infrastructure is taken care by the cloud vendor. So what you do, you build your application, host it in this environment, and at the same time, you take care of the scaling aspect. So when I say scaling, so you need to go and explicitly say, like suppose my CPU percentage goes beyond 40%, then what will happen is your application should scale. So this scaling aspect, that is one of the example. Another aspect is, okay, before I get into this, all of you understand what scaling is, right?
Yes.
Yes. Okay, cool. Then I'm sorted. So what happens is we need to do some auto scale settings. Like one of the example I already gave you, like if the CPU percentage increases manifold, then it should scale. So we can define those percentage. We can do those settings. If you say that your memory usage hits this much, or disk ops usage hits this much, or you can also say like on Monday, like the example I gave you, like, or let's say like 25th of December, it's my e-commerce application. On 25th of December, I'm going to expect a huge amount of load. So I can make those settings for my application on a platform as a service that on 25th of December do scale to this much number of instances. Okay. So all these settings I need to do in the case of platform as a service. Okay. But again, platform as a service is a cheaper alternative to infrastructure as a service. The reason being, most of the times, not always, mark my words, it's not always, most of the times this infrastructure is shared across multiple like applications. So, or rather I'll say like the hosting environment on the operating system. So it might so happen that you have a virtual machine and you can have multiple PaaS applications from different vendors or different persons sitting on the same virtual machine. That means you're sharing the environment. That is the reason why like this is a cheaper option. So all these three tiers are shared across multiple applications. Since you are doing the sharing stuff, so it's a cheaper one. But again, you're not restricted to this. You can also like reserve your dedicated instances. There are different plans available. I'm not getting into that. So using different PaaS-based plans, you can also have your like environment or have a dedicated environment where you can run your application and it will behave same as your virtual machines. Okay, so the advantage that you get here is like now you'll ask me, right? So if I'm why should I go for a platform as a service? Like it's a dedicated environment, right? So like if I'm taking a dedicated environment, why shouldn't I go for an infrastructure as a service? The answer to this is, so like see, if you're going for a platform as a service, so you need not maintain the operating system and the hosting environment. All the patching work and everything are done by the underlying cloud provider. But here you need to own that responsibility. So you get saved from this responsibility. Though you incur cost, but you get saved from the responsibility. So that is why mostly like even though at times we run a dedicated environment, we choose platform as a service as an architectural decision. And trust me, like it's managing the virtual machines or the operating system in the hosting environment is a pretty headache. So like I have seen like Microsoft, there are few services or like at times also for few operating systems, we get patches very regularly and your organization will be pushing that your VM should get updated as soon as possible, or else like we are going to show in red in our vulnerability scans and all, and you will be chasing your hosting environment and operating system, patching it always and incurring a lot of cost. So all this cost will get saved here, and also like the efforts when you are using platform as a service. Okay. Then we have the serverless model, which is a cheaper option, but again, there is a star to it. So it depends on how you design your application. Based on that, like you can say that serverless is cheaper than PaaS. Not always it is cheaper than PaaS, but there are scenarios, or you can design your applications in a way that you can save some bucks, like as compared to platform as a service. So what happens here is, so here also like you don't have a control over the hosting environment, operating system and infrastructure, as well as the scaling. So here actually you need to explicitly mention that I need to scale to this instance whenever my CPU percentage hits 75%, then it should scale to an instance. But here actually your underlying platform takes care of all the scaling aspects. You need not worry about any kind of scaling aspects. You just need to build your application and host it, and everything is taken care of by these underlying tiers. So that is what serverless is. So you don't have any control over the scaling aspects, but again, there are a lot of design considerations you need to take care of when you are building any serverless applications. So I'll come to that in the future slides. And there are also disadvantages to it, like when we allow when you don't have any control over the scaling, and whenever there will be a incoming surge in traffic, lot of instances will get spin out, and there will be cost incurred also, because each of the instance will have its own cost. So suppose I'm running on a single instance, then it is cheap. So then now like I have 4 instances, then you need to pay for the 4 instance. Like the load still increases to tenfold, then you need to pay for the 10 instances. So these are the disadvantages with the underlying platform. But again, like you are getting saved from the scaling aspects. So that is what is serverless on Azure is, and this is how the model comparison looks like. So any queries here before I move ahead?
Abhishek, then how to know that when the Azure function will be scaled up or when the Azure function will be scaled out? Is there
Uh,
any by chance we can get to know?
yeah, you can do it. You can use the metrics like see, we have Azure Monitor. Okay.
Yep.
In the Azure Monitor, like you can see the metrics, and from there you can deduce.
Okay. Yes.
But you don't have a control over like when it will scale out and scale down. There is a scaling controller that is involved in the background that does the
Okay.
trick.
Okay. Okay. Yes.
Okay. Any other questions, or I'll move ahead?
Yeah, Vishek, I have one question. Regarding this invoking of serverless functions or logic apps, so is there any limits like request limits or API limits that is there
There
for?
there are limits. So like even invocation, your concurrency limits are there. So at a single point of time, you'll be able to like maybe like each of the services have their own limits. So yes, there are limits.
Okay. Okay.
And you need to, it's a very important question that it's good that you asked. And these all are the inputs for the design considerations. So whenever like you are designing your application on serverless, so like you need to take care of all these limits and all. So
Yeah.
basically, I'll tell you the success of serverless is the way you are able to control the scaling.
Okay.
Maybe I thought I'll touch it upon later, but since you've asked this question, let me tell you. So there are limits. So what happens is, suppose you have designed an application, okay, using serverless. You have your
Mhm.
Azure function, your backend is Azure MI, okay,
Okay.
Azure SQL MI. So Azure
Mhm.
SQL MI or a managed instance is not a serverless offering, okay.
Yes.
Okay.
That means it can't scale on its own, correct? Or
Yes.
like maybe you're using some kind of PaaS service that cannot scale. Okay,
Mhm.
so what will happen is whenever like your Azure function will get a request or any surge in requests, like 1,000 requests, your Azure functions will be able to scale. That means there will not be any kind of bottleneck near the Azure functions. But all these requests, see now, I suppose like for 1,000 requests, I have to say like 500 instances catering to the 1,000 requests, and all these 500 scaled instances of the Azure function, they will hit the backend of Azure MI, Azure SQL MI, right? So there it will be the bottleneck because it will again hit the limits and you'll get deadlocks, right?
Yeah.
So
Yes. Yes.
we need to control the degree of scalability. So we use techniques like queues. We use queues where we say that I know that Azure function can scale to a very huge number. So, but I need to control the scaling that at any one concurrent point of time, it should scale to only 10 instances. Okay, for that I can use queues or service bus queues or the lot of different kind of queuing mechanisms available in Azure, where actually I can take all the requests and at a single point of time I'll be fanning out to 4 or 5 number of instances. My scale I can define my control my scalability limit. So this is one of the considerations. Anyways, I'll touch upon again.
Yeah. Sure. Thanks.
So let me quickly brief on. So what are the different services available for serverless on Azure? So, and okay, let me call out very explicitly, serverless is nothing to just limit it to your Azure environment. You have serverless offerings on AWS. You have serverless offerings on Google Cloud Platform also. And you can use all the serverless services like in a mix and match. So normally I do it in my designs. So if you see my designs, normally my designs they map to multi-cloud architecture paradigm. So where we use different components from different cloud providers to avoid vendor locking and get the things run. So serverless offering is there on all the cloud platforms. Okay. So on Azure, we have Azure Functions. Using Azure Functions, what you can do is you can write a shorter piece of code, and you can combine all these Azure Functions together to have some kind of a microservices kind of applications or build any kind of a function as a service programming models. Okay. So also we have something called as durable functions. That is where suppose in you are writing an Azure function. So Azure functions are stateless. So suppose you need to bring in state to them, or like you need to like have some kind of workflows, or you need to have some kind of orchestration kind of thing involved. Then you can use something called as durable functions. I have not mentioned it. The advantage of durable function is like you can orchestrate different functions using that, and at the same time you can also like save state for the Azure function. Another excited like another awesome service is like Azure Logic Apps. So it is workflow based. So you can define workflows. Like for example, normally we have workflows, right? When we get a request, then step one is performed, then step one is performed, then step two and step three are performed in parallel. Then step four is performed after this step three is performed. So there is a defined workflow. So this workflow kind of activities can be handled using Azure Logic Apps. But again, they can also be handled using Azure functions like Azure durable functions. Now your question is like when to go for Azure Logic Apps and now when to go for Azure durable functions. Okay. So whenever like you are a programmer, So like you should, like normally you will be at ease of using Azure durable functions. But if you are not from a good programming background, so you can take help of Azure Logic Apps, but you can use both Azure durable functions as well as Azure Logic Apps to build workflow kind of environments. Okay. So what is the next next service available? That is the Azure Event Grid. It is nothing but it's a event, yeah, like it's an event platform. So where like you can have highly, and it's highly scalable. Like thousands of events or requests can get ingested into Event Grid, and it's a publish pub sub model. So like once like events are like ingested into the event grid, there will be subscribers who can actually consume these events and get going. We also have a serverless SQL database, but the design guidelines and the design considerations are that do not use Azure serverless database with production environment, because there is something called as a like a delay start. So I'll come to that to the delay start, but don't worry about the delay start. I'll explain it in detail what it means. But from the production guidance perspective, it should be only used in development or UAT environments. And the serverless SQL databases, like they're good for development environment because they save a lot of cost. Only when you are querying the database, then only you will be get charged. And storage, of course, you will get charged. But the read writes, it's a very different chargeability model from your Azure MI or normal Azure databases. Then we have the Azure Container Instance. This Azure Container Instance is used inside Azure Kubernetes Service to create your, they're used as the serverless nodes on Azure Kubernetes Service. So I'm not touching deep into that AKS part. It's a big area. So just remember, it's a container-based offering using Azure Container Instance. You can run the containers, and inside, and AKS is a container orchestrator. So you can orchestrate a lot of containers using ACI, and this ACI you can run inside your AKS as serverless nodes. So when I say serverless, like they get called on demand. Else what will happen is the nodes are normally virtual machines in AKS, and virtual machine nodes are pretty costly, because always like VM we need to shell a lot of amount of time. When we are using ACI, then it's a serverless offering. So like I'll only get billed whenever I'm using it. I'm not reserving any virtual machine for it. Okay. So these were some of these offerings on Azure, and a lot of serverless offerings are coming. For example, like very soon, or I think Cosmos TV also has a serverless offering nowadays, and a lot of new serverless services are also coming up. Okay. So let us discuss on few of the characteristics of the serverless thing. So one is like it is cost effective, definitely, because you pay only when you are consuming it. Whenever your service is idle, you are not consuming it. So you need not worry about the scaling aspects, because they scale in and scale out effortlessly. So the underlying platform takes care of the scaling aspects. You need not worry about the scaling aspects. You need not do any kind of settings for the scaling aspects. Then it supports on-demand execution. So it executes only when you need it, or you invoke it, or it's triggered. Whenever you trigger the service, then only it gets invoked. And most importantly, this is applicable for Azure functions. You should use Azure functions for shorter execution time, because they're meant to be executed for a shorter duration of time, perform the activity and come out. So if you have a long execution code, piece of code, or a long running code, like break it into smaller pieces, and then like call them one after the other using durable functions or something, or directly also if it's a simple like simple calls, then you can use Azure functions as is. Then it's no host. That doesn't mean that it doesn't have a server, but you don't have a control over the server. The underlying infrastructure is managed by the underlying cloud platform. You need not worry about the underlying infrastructure overhead. So it's all taken care by the cloud platform we already discussed. And the best part is I love about the serverless is the faster time to market. That means what will happen? Suppose you're building an application. So we normally request the environment delivery team to build a VM and give it to us, and then we host our applications there. Okay. So and once you have the VM, then you need to patch it. You need to like have your hosting environment set up. You need to have all your different installables done. So all these activities you need to do, right? So it will take some time. But in case of serverless, what happens is you just need to build it and host it. You need not worry about the underlying hosting platform and all. So that is the reason why it has a faster time to market. It is highly available. So like it's just like a PaaS service. So like your Azure vendor or your cloud vendor guarantees the availability. So you do not worry about it. And at the same time also it's elastic. So who can explain me what elastic is? Why we call this as elastic? Any idea, any guesses why we in a design paradigm, what elastic is?
Uh, Basically, based on the demand, it automatically scale out. Whenever there is a less demand, it will automatically release the resources.
Okay, cool. You are almost 80% there. So I'll just bridge in the next 20%, but good, huh? Like you could touch upon this. So when we say elastic, elastic means so like it can scale, but it has a limit, a rubber band. So you can't stretch a rubber band in infinitely, right? When you like stretch a rubber band, you have a limit. After that, you won't be able to stretch it anymore. Correct. In the same way, so what elastic is so you will be able to scale. So like I like someone asked, right? We had a question, right? Does it has limits, concurrency limits, scaling limits, and all? Yes, we do have limits. So what it means is though we have limits because it is elastic. That means we will be able to scale, but there is a limit. So we can't scale infinitely. We can say like we can scale to a big number of instances, 1,000 instances, but we cannot go beyond that instance. That is why it is elastic. We can scale, we can scale in and scale out, but we have a limit. We won't be able to go beyond that limit. That is the reason why it is called as elastic. Okay. It's a normal design consideration and it applies good for any of the design principles you are working on. Okay. Now let me come down to the design considerations. Okay, before I get into this, all of you are with me, right? You guys are getting what I'm trying to put in here.
Yes, sir.
Okay. So as part of design considerations, so when we design any kind of serverless solutions, so what we need to take care of? So like how we should plan our application. So normally, right, whenever like we build any kind of applications, so we design it, right? And before designing it, we just don't go on a pen and paper and start designing it, or we don't simply open the Visio. You won't find your architect opening the Visio and start building the blocks right from the scratch, right? We have some design considerations in place that we need to take care of, correct? So let's see, like every application has its own design considerations. In the same way, the serverless also has its own design considerations. So what are those considerations? One is most importantly, the cost planning. You need to plan for the cost. You need to go and ask your customer or your stakeholders. So what is your cost? You are saying you're asking me to build a serverless solution, but what is your cost? So why it is important? Because in case of serverless, we know that it can scale like the underlying platform excuse me, performs the scaling aspects, right? You don't have a control over the scaling. Today you have a single instance. You are getting charged for a single instance. Tomorrow you have a huge surge in traffic. That means you will have multiple instances serving your request. Then you will be charged for the multiple instance. So you don't have a control over the cost if you're not planning it. So you need to come up with the cost planning and accordingly, like you can choose your services and say that yes, like I can take this plan and this plan allows me to scale to this limit. So you can choose your hosting plan, or like you can do some kind of mechanism to control the scalability. Like I discussed, we can have a queue and then from there we can fan out. If you are from AWS world, you can have SQS and normally SQS and what is the other thing? SNS are used to like control the scalability of lambdas. Okay, so this kind of mechanisms you need to build in and bake in and do the cost planning for that. The second important thing is startup delays. Let me try to explain you what startup delay is. Okay. So, okay, before I get into this, I know like a few of us are already hands-on in serverless. So what is a startup delay in case of serverless services? Anyone would like to explain me?
It's more like the cold start that we face, like we don't have instances running throughout. There is
Yeah,
an event which fires or, which makes our functions run, as any of our serverless offering run. So there is a delay when the actual functions or any other serverless service starts. So that delay is what we say, startup delay, we can say. So it happens one
exactly.
time.
Yeah, exactly. That is what it is. It is bang on like what I'm going to explain now. So how it happens is you have a serverless service. Okay. Whenever you're invoking it, your service starts running. Okay. It runs for 10 minutes, 15 minutes, 20 minutes, or after 20 minutes, like your processing completes, it has a limit. It cannot go beyond a particular time limit. Then what will happen is your execution completes, your service has done its job, and then it will go to sleep. Okay. It goes to sleep. Then when another invocation will happen, there will be a cold start phenomenon. That means it cannot spring into action immediately and start working. Okay. So it will take some time, say like 10 to 15. Sorry, it's not that. You can actually control that also in some services. Like it takes some seconds or at times minutes, but hardly. But there is some time it takes to wake up from the sleep. So what happens is after the function is done with its activity, or let me take an example of the Azure serverless SQL database. So you hit a query, you're working on it. After that, you are not working on the database for some time. Then the database goes to sleep and you need to wake it up before you can start using it. Okay. So when you're waking it up from its sleep state, it takes some time to spring into action or start up. So there is a delay. So whenever you're requesting the service, if the service is in a sleep state or it's not active, it's in the idle state, you need some time to wake this service up so that it can come back and start serving the request. So that is the startup delays. And whenever you are designing your applications, you should factor in the startup delays. Or else what will happen? Suppose you're working on an application, like say like a payment gateway kind of application, and you're using an Azure function there in the payment gateway. Okay. So and that Azure function is working on the consumption plan. So what will happen is uh, immediately after this Azure function like completes, it will go to sleep. After it does a payment activity, it will go to sleep. And when the next person is trying to do a payment, it will take some time for the Azure function to come up. And by the time it comes up, your gateway will time out. So you fail in that area, right? You are unable to do the payment processing. So that's why like it's an example where you can see that why the startup delays are useful. So any queries here in case of startup delays, guys? We're sorted,
Yeah.
right?
Yes. No. It's good.
Okay, cool. The next thing is the stateless. So like we say that our applications are stateless. I mean to say like we write a lot of stateless applications. So when you are building any kind of serverless applications, normally inherently they're stateless. Or if you go to Azure functions, specifically this particular word is targeted towards Azure functions. In the case of Azure functions, your Azure functions are stateless. That means you cannot inherently keep the states or sessions or anything there. Okay. So what you need to do is if you need to manage the state, you need to use some kind of Redis cache or some kind of state management mechanisms, or like best is you go for durable functions that can make your Azure function stateful. Okay. So, and it's a very important behavior like this stateless you need to consider. Inherently, they're stateless. And the challenge what you'll face is, let me give an example and tell you. Suppose you have built a shopping cart application. Okay. In a particular call, you're coming to your application and you're adding two items. Okay. And when your item is added on, say, instance one, it has scaled to two instances. Your Azure function has scaled to two instances. Azure function has added two items in, assume that it is in memory in instance one. For the second time, when you come to make the payment on the next call, for some reasons, it goes to the other instance. You won't be able to make it out what was added in the shopping cart in the first instance because it is in the first instance. Now you are operating on the second instance. So you will see your cart empty. So this kind of issues you will face. For that, you need to like handle this stateless. You need to like have your mechanisms in either use durable functions or Redis cache. So those kind of coding techniques you need to use. Okay. The next important point is the execution period. It is a very important considerations. Your Azure functions times out after a particular time interval. Maybe I don't remember the exact limit. I believe it's 20 minutes, 15 or 20 minutes. After that, it times out. So you need to plan your code accordingly. Azure functions or your serverless executions are meant for a shorter time period executions. So you need to divide your entire long running code into smaller pieces and run each of the pieces in each of the functions. Okay. Then the next thing that you need to take care of is the communication and integration. I told you like when we have a long running functionality, we are breaking it into smaller functions and running it, right? So then I need to make the communication happen between all these functions, right? This function should be able to communicate among themselves like efficiently. They should be able to integrate among themselves efficiently. How they can do it? So you need to bring up with a strategy. Maybe you can use a queue, like a storage bus queue, or a service bus queue, or like you can use some kind of a simple storage queue, like a different queuing mechanism you need to bring in. That will help you in managing the communications and integration among the Azure functions. You need to pass on some data. So from one function to another, whenever we are breaking down your functionality into smaller functions. Okay. Then the bottlenecks I've already touched upon. So like maybe like you are having a serverless service. So in case of serverless service, they can scale automatically, but your next service may or may not be able to scale. Like the serverless service is calling another service, the other PaaS service is not able to scale. So you're transferring the bottleneck there. You need to control this, the scalability here. For that, you can use queues or different fan out mechanisms to control the bottlenecks. Most importantly, you need to have the retry mechanism defined. So when I say retry mechanism, so it's very important that you need to define like some kind of retry patterns. For example, in the code, in your application code, you can keep monitoring like whether your operation got successful. If not, then again like do a retry. So you can define like it can retry for 3 times. So this thing you need to take care of. And another is like monitoring failures and logs. So monitoring is a very important aspect here, because when we say serverless applications, normally the serverless applications consists of lot of services. So a lot of services will be generating tons of logs, and you should be efficiently be able to play around with the logs. Maybe you can use Azure Monitor, and in my cases, in my designs, normally I prefer using App Dynamics. It's a third-party service provided by some other third-party vendor. So we use App Dynamics, or you can go for Prometheus offerings. So there are so many ways of monitoring failures and logs. So, but again, like you should be able to identify why your application has failed, why your function has failed, or why your serverless logic app has failed. So all this information you should be able to have handy, and you should be able to debug it. So that is why we need to monitor the failures and logs efficiently. So any doubts in the slide?
No.
Abhishek, one question from my end. Like, how do you handle the failures and logs? Suppose one of the requests, your function was unable to process. How do you mitigate these kind of risk associated while handling an production ready application?
In production ready applications, you should have a circuit breaker pattern there. Okay. So the reason being, I'll answer this in 2 stages. So first is like from the application perspective, you should have a circuit breaker pattern there. So what will happen is, suppose like you are ingesting a lot of items in the queue, your function is picking up one queue and processing one by one. Take for a scenario your function goes down, or some kind of functionality is not working in the function. The function is able to dequeue the item, but it's not able to process that item. You can have a scenario read like this, right? The function will dequeue the item, but it will not be able to process that item. So what will happen? You lose the items in the queue, right? Your items are getting dequeued or picked up from the queue, but they're not getting processed, and I lose the items, right? So you need to track that. So for that, you can have a circuit breaker pattern. Whenever you see that the function is popping out any item and it's not able to process it, then you should be able to break the circuit, break the processing, and push that item to a dead letter queue or somewhere from where you can pull and process it. So that kind of mechanisms you need to have in place. It's very important, and you can use durable function to use this. Coming to your second question, how to monitor the logs and all, you need to enable application insights or loggings in your application code very efficiently. See, it is your application code and you know it better, its functionality as a developer. So it's your responsibility to like chip in all your I mean to say your logging mechanisms. So and once you have generate all these logs, you should keep it in some kind of like maybe you can use log analytics workspace, or you can use app dynamics somewhere, like you need to ingest and keep it from where you can actually monitor and see it. And also at the same time also you should have alerts configured. So when the function fails, it will ingest a log, and at the same time also it will send an alert to you. So these are some of the mechanisms by which you do it at each of the function level. That answers, right?
Yes, thank you, Abhishek.
Okay. Okay, so by now, so we discussed a lot of theoretical aspects. Now let us get into a problem statement, and we will try to build a solution for this. And it's a pretty important use case in today's world if you are from the retail industry. Okay, so I have an e-commerce startup that is looking forward to build a cloud-based solution. They have some kind of on-premises solutions, but now they want to go to the cloud. And the functionality they want to achieve is like the order processing. That means customers should be able to place an order, and your application should be able to like send it to the backend team. So for example, like you deal with some kind of a retail garment or like retail clothing industry. So like where like you'll have your Levi's or Lee or like Jack and Jones or different vendors out there. So your customers can come in and place that order, and that order will get redirected to the appropriate backend team, maybe Lee or Levi's or Jack and Jones, the corresponding application, like corresponding vendor team, and they will process the order and send it. And at the same time also, like we know the social media sites, right? So whenever the user like they're not happy with something or they're really happy with something, they tweet. Like we also do tweet, right? At the rate this in Twitter, like I don't like this, or in Facebook, I don't like this about your product, or I really loved about this product. This kind of feedbacks we give, right, in social media, and we tend to use it a lot. So the company thinks like strategies that it wants to use this kind of like social media handles. It should be able to monitor the feedback in the social media handle and improve its performance. It needs to know like what customer is feeling about it. So two aspects. One is like processing the order. Second aspect, we need to process the social media tweets. So these are two of the functional requirements. The company also has some non-functional requirements, the NFRs, like the user should be able to authenticate the users based on Google and Facebook credentials. Okay. And it should follow the security practices like single sign-on, multi-factor authentication, and all these things like CORS, like they should have the CORS enabled. So all these things should be there. And also, the application should be performant. Like like an e-commerce application, normally like whenever we have discount, we see a heavy surge in traffic, right? Whenever we have discount in Amazon or Flipkart, so what we do? We simply log in and we buy as much as possible. So at that point of time, your application will experience a surge in workload, and the application should be able to handle this in a very performant manner. So this is my problem statement, and let us see like how we can build a solution around this. So all of you got the problem statement, right? Is there anyone who doesn't get this? All
Yes,
are good.
Abhishek, we got.
Okay, cool. Now let's come to a high level architecture. So how it will look like. So for the customers, normally see whenever we write any kind of serverless applications, we try to build a SPA based solution because we can host it in a very efficient way. Like we can do a static hosting that is much cheaper than other hosting options. That is the reason why I have selected Angular application that would be the front facing for the customers. And I can host this Angular in a static hosting manner, and I can save some cost. Instead of going to our web app and all, I can host it in my bucket, S3 bucket. Okay, sorry, I'm talking about Azure. I can host it in my blob storage, right? I can
Yes.
as a static hosting, and I can save cost. So that is the reason I picked up Angular hosting. And a few of the folks I'm pretty sure you're aware of these hosting mechanisms since you're working on serverless. This is a standard followed. And for we have an order processing module that talks to the backend vendor teams. We have a feedback processing module that talks to the customer relationship management team. So this is the high level architecture. Now let me go to the next step where we will build this Angular application. So what we are going to do now is we'll build each of these components and integrate it. Okay. So in case of customer facing application, so what we can do is we can host our application in this inside a Azure Blob Storage as a static hosting, and we can keep maybe like you can ingest your logs to App Insights, or else like you can keep your auditing data, or normally like also like we use a lot of static data, like we use database, right? We can't have an application which cannot work without a database. We don't have any application that works without a database, right? We have a database. So I have selected Azure Cosmos DB as it is a serverless offering. So recently they have come up with a serverless offering. So all the data purposes will be handled by this Cosmos DB. And anyone of you tell me like why I have chosen Azure Active Directory here?
For authentication and authorizations.
Okay, but I could have done it using other ways, right? Why specifically I chose Azure AD, like going back to the problem statement?
Yes, because Azure Active Directory actually gives us the B2C products. So you already mentioned there that you have the Google authentications as well as Facebook authentication. And we also have Azure services over here like Cosmos DB or Blob Storage or our future Azure functions you will be building. So for that, Azure Active Directory will really be helpful because it will actually create one kind of organization, and there we can have multiple customers and multiple users in a single base.
Okay, awesome. Actually, that is the reason why. Good job, huh? Like you explained it very nice way, and that is the reason why we have chosen Azure Active Directory. So we had two major requirement, a B2C requirement where your users are expected to log in using Google and Facebook, that is supported in Azure Active Directory.
Yes.
That's the mechanism. Your Azure Active Directory supports single sign-on. If you go to the problem statement, it talks about single sign-on. Okay, and also like multi-factor authentication. So all these are supported by Azure Active Directory. That is the reason why I have chosen Azure Active Directory. So your customer will authenticate themselves using the Azure Active Directory. Then your application hosted on Azure Blob Storage will serve the request. There is one component missing here. So I didn't put it because I wanted to keep the things simple. Between both of them, Azure Active Directory and Azure Blob Storage, there has to be CDN here. Okay, so that will improve the performance of your application. Normally, that's how practice followed. So normally we have a CDN, and that CDN we integrate with like a domain normally. So don't just forget those CDN part and all. So don't worry about that now. Let's keep the thing simple. I just called it out for advanced users in this forum that be aware that we need to have a CDN here. Okay, and once your customer places the order using this portal out here, then your order will get either get into the order processing module, or it can also have some feedback forms. Okay, form based feedback, not necessarily from the Twitter and all. So it can go to the feedback processing module. Okay. So they can also have a bot, right? Chatbot sitting, and it can also like give some kind of feedback, not necessarily Azure bot service or Python based chatbot, any kind of chatbot, like it can be there. And there also user can give the feedback. So that's why like I've kept this block here. Okay. Now we have designed the customer facing application. Now let me design the order processing application. So from the Angular application, all one thing just note here, though I'm your Azure Logic Apps is a serverless service, right? It can scale, but I need to control the scaling, or like I need to bring in discipline in the way the Azure Logic App scales. That is why I have the Azure Service Bus queue here. The Angular application will be ingesting your all the requests in this Azure Service Bus queue, and this Azure Logic App will pick up the items from the queue and process it. And once it processes, I'm using this SendGrid service. It's a Mailer service, a third-party Mailer service available as a PaaS service in Azure. So you can use SendGrid. You can create a SendGrid account in Azure PaaS, and you can send mails. So I'm using the SendGrid service so for sending the mails. So what are the steps? Your Angular application will ingest your request into the service bus queue, and your Logic app will pick up the items from the service bus queue. And definitely we need a database for our process, like for data and all. And then it will send your request to the SendGrid account. The SendGrid account will trigger a mail to the backend vendor with all the request details. So that is what the order processing module does. Now let me do the feedback system. Okay. So I told you we can also have a bot sitting in giving the feedback. Okay. Also, it can monitor the feedback from a Twitter handle. Correct. There are two routes to it. Suppose you have a bot, or you get some feedback from the feedback form inside the Angular application. It will trigger the Azure function. So the Azure function will call the text analytics API in cognitive services that will analyze the text and bring out the analytics score out of it, like whether it's a negative sentiment or it's a positive sentiment. It can bring in the sentiment, and it can trigger a mail using SendGrid to the customer relationship management team, the CRM team. Okay. Also, I said that we also need to monitor using the Twitter handle. So you can use the Logic App for that. Why I use Logic App is because using Logic App, you can easily integrate with Twitter handle. So there is a connector. Azure Logic App has a lot of connectors. Maybe if I get an opportunity next time to speak on this forum, definitely I'll bring in either Azure Logic App or some other areas out here, and I can pitch in how it does. But at this point of time, just remember Azure Logic Apps, they have connectors. So Twitter handle connector is one of them, by which it can easily pull the tweets from Twitter handle, and it can analyze here using steps. Again, it can also have connector for cognitive services. It can connect to the cognitive service and do the analysis or text analytics out here, bring in the response of the sentiment of the user, and then it can send a mail to the customer relationship management team. So any doubt here? It looks a bit complex, but it's pretty simple. So any doubts here?
Yes, Abhishek, this one with the SendGrid account. There are certain issues with the SendGrid account normally which we face. In one of my application which I was making, some of the mails that my client was using while sending the registration or forgot password mails using SendGrid, there were some of the there were some mails which were not being forwarded, and they were being stuck there inside the SendGrid server itself. So they were not moving ahead. So I had no other alternative way of doing it. And secondly, I cannot track those things apart from getting inside the SendGrid dashboard. So can't we have any other way of integration, like typically we have in an web application, we use some of the native libraries, SMTP libraries. So is there any way to integrate that with Azure function, or do we need to
Yes, you can.
SendGrid?
You can actually. So I'll tell you, in our organization, what we have done is we have built a SMTP based service and hosted it on Azure Web App, and we are calling that as a sorry, it's an app service. Okay, we have built an SMTP service and hosted it as an app service. So then we are invoking those SMTP service. It is shared across multiple applications. You can use that actually.
Okay. But one component of the whole architecture doesn't come into the serverless component again.
Okay.
So how do we mitigate? How do we ensure that all our components scale in a serverless way? Like we can enable auto scaling options inside our app service plans to do that. But again, we have we have to pay the cost irrespective of the fact whether we are using that or not. So how do you address such concerns?
You have my simple answer to is that we have to live with it because serverless world is evolving and daily we are seeing new services coming across and we never know like when we get a serverless offering for that service as well. So we need to live with it. And at the same time, also very important that we need to handle the bottlenecks by using queues.
True.
That answers right because normally see all the we have a limited number of services right in serverless. So all our services may not be, for example, SendGrid is not a serverless service. That is why like it's sitting, you said, right? It sits on the server and it doesn't go. That is because of the bottlenecks. So you need to either like find out the exact root cause why it is not going, talk to the SendGrid, or rather like best thing is like talk to the Azure customer support, highlight them like why it is happening, like try to find out the root cause. So check if you can manage the scalability of the serverless service. But again, we don't have a serverless mailing option, or like there can be other components also, like maybe for example, text analytics. So we don't have a serverless offering for cognitive services. So all these things we need to live with it as long as we get a serverless offering for that. So basically, what I mean to say is, pure serverless designs, it's very difficult to build because we don't have everything serverless offering with us. So it's not just on Azure, in other platforms also. That answers, right?
Yeah, got it, Abhishek. Thank you. It was really informative.
Yep. Thanks. So others also, you got this feedback system, right? You guys understand what cognitive services is?
Yes, Abhishek, but I have a question. What exactly Azure Cosmos DB is doing here? I mean,
It's
in
just a
this.
database storage actually.
Okay, you
So
are just storing it.
maybe any application will have some kind of data storage and all happening, right? Maybe
Okay,
audits,
okay.
for example. We keep audits of the transactions and all.
Yes, understood then. Yeah.
Okay. So here I have combined everything and I've kept it in one plate. This is how your entire architecture will look like. So I have my Angular application hosted here. Your customers will uh, give a request out here. And also like we have the API management. Who can tell me why we need API management here?
I am actually using it API management. So it's
Okay.
kind of an gateway.
Okay.
So we are actually routing our system to whether it will go to the order processing module or whether it will go to feedback module. So it will be acting as a pass service
Okay.
in between the front end as with respect to the back end. So it
Okay.
will be the connector over there. And second, we can actually manipulate all our API related routes queries, I mean request queries inside the API management.
The
We have
headers.
policies for that. Hello.
Yeah. 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 Go
Yeah.
ahead, please.
Yeah, we have policies for that. I mean, inbound, outbound rule will be there. So we can actually mask our routings so that if there will be some guy who will go to the security and check that, yes, we are routing to this path, they will not going to understand that it is the actual path or not.
Okay.
For that reason also, we use API management.
Yep. In a nutshell, we are controlling the security behavior of the entire application. So we
Correct.
have
Yep.
routing, we are able to achieve routing, and at the same time also you can define the CORS policy. You touched upon the policies. You can define your CORS policies, and also you can say um, not just CORS policies. It's much more than that. So you can have a complete control over the headers, the request and the response headers. You
Yes,
can see
yes.
are there any malicious headers? Then reject those requests. So you can get a hacker, right, who can bypass this and directly call these functions, because you can do an HTTP calls for your Azure functions, right? So these hackers, like how to handle these hackers. So here actually in API management, you can monitor the request and the response that you get, and you can bring in those security mechanisms. That is the reason why we have this. And again, I have ordered all the boxes out here.
I'd like to add up one more point, Abhishek. It would also allow us to restrict the number of requests that is being served to our functions.
Yes, that is very important. That will control the scalability behavior of the function.
Yes, we can write it in the policy. Yep.
Yeah. Okay. that was all I had for you guys. I think I went a bit overtime, like 10 minutes. Apologies, Ashirwad.
No
I
issues, no issues, Abhishek. It was really helpful, and we don't regret going beyond the scheduled time. We would have loved it if it went on long more. I think other people would also agree with that. So, guys, if you have any questions, just throw them at Abhishek, and Abhishek is open to answer them.
yeah, but
Abhishek, I
uh,
have some small question. Yeah, yeah.
okay.
Please go ahead. Yeah.
Okay, before you start on, guys, just hold on. We have a quiz, and based on the response, you will be getting books, free book.
Okay. Yes.
Okay. Yep. Yeah, please go ahead with your question.
Yes, so right now I'm actually going for the architecture way of designing the serverless platforms. So when to use Azure durable functions and when to use normal Azure functions. I mean, if I'm going with respect to the architecture, for a single durable function, we have one orchestrator function and one activity function. So it's
Okay.
like I have to run three functions over there, like
Okay.
two times orchestrator functions and one time Azure functions minimum.
Okay.
But in normal Azure functions, we can go for two Azure functions and one queue mechanism to
Okay.
communication for the
Okay.
communication. So when to use what? I
Okay.
mean, those have the pros and cons. So when to use what?
Okay. So see, whenever you are using durable function, so like whenever you have a stateful application, you are building a stateful application. You mentioned queues, right? Whenever you are using Azure functions, inherently you use queues to make it stateful. But all
Yes.
these come inbuilt in Azure durable function. So whenever you see that you need to manage the state and all, it's not just a simple processing. For example, any kind of CRUD processing or all. So go for durable functions because there you can manage the state. That is one reason why you should choose Azure Durable Function. Another reason for using Azure Durable Function is orchestration. So using Azure functions, you can build simple orchestrations, but think of us complex orchestrations when you can have two parallel activity functions running. They will complete and they'll merge into the back to the orchestrator function. Then again, like there would be another activity function. From that, another two parallel function will spin out. So whenever we have a complex orchestration scenarios, go for durable functions. And durable functions comes up with all these queues and all right tables. I think they use table storage for keeping the states. They manage the
Yes.
state
Yes.
for each of the steps. They keep the retain the states.
Yes. They have event sourcing over there.
Exactly. That is called as event sourcing. Event sourcing is enabled for Azure durable functions. So whenever there is state is involved and you have so many functions to orchestrate, you need to go for durable functions.
And sir, how to actually go for logging mechanism in the normal Azure functions if I am actually considering a function chaining pattern for
Okay.
my architecture?
Okay.
So how to log it? I mean, in durable functions, we can actually log it in the parent orchestrator functions,
Okay.
right? So we can have a try catch block over there.
Okay.
So it will be bubbled up. All those exception will be bubbled up and simply we can log it over there. But in normal Azure functions, we have a chaining mechanism. So
Okay.
how to log it? I mean, I have multiple instances of logging log my custom logs,
Okay.
but how to centralize it in a single
See,
step?
for that you need to use see like what you need to do is first of all like you need to have a centralized logging storage, for example a single log analytics workspace or
Yes.
some kind of centralized storage, and each of your function your application code can go on logging right there.
Okay. Okay.
So again like no bubbling is you won't be able to bubble anything out here.
Okay. Yeah.
You don't have event sourcing right in normal Azure functions.
In normal Azure function, we don't have.
Okay, one thing I missed on. So when to use IIS, PAS, and serverless. I'll just quickly in just 2 minutes. I will touch this upon. Then I will release the quiz for all of you. So normally what happens is whenever you do any kind of assessment. So we don't like whenever we do any migrations or like we build any applications, we do an assessment of an existing application or like we see the requirements. So if you see, we have a PaaS service available or a software as a service like SaaS service available. So what you do is you try to consume those service, or like you see like whether there are any serverless, whether it can be done using serverless mechanism, then use that. Okay. Suppose you feel that there are some components you are finding it very difficult to move it to serverless or PaaS, then consider to leave it as is on IaaS. Or you, if you still want to like do away with the IaaS, try to see if that component can run as containers. Okay. So that means you're doing away with the virtual machines and you're running your workload in the containers. Okay. So your first preference would be serverless or PaaS. If you it's not happening, then go fall back to infrastructure as a service, host it on VM. But at the same time, just make a choice like design decision whether it can run it on a container. If it can run it on a container, well and good, run it as a container. If still it won't be able to run it as a container, then leave it as it on infrastructure as a service. So that is how your lift and shift mechanism works.
Okay.
Okay. Any other questions, or I can release the quiz?
Yeah, Abhishek, one question I have.
Yep. Yeah. Tell me.
So, as you said, like in Azure Logic Apps, we have different connectors, right?
Hmm.
Using this, each connector will incur any cost, or like only the trigger of Azure Logic Apps will incur the cost?
It will depend actually. So, for example, you are using a SendGrid. Na? For SendGrid account, you will have a cost.
Okay, okay,
So it will depend. But if you are using a Twitter connector, you are not charged. It's just the invocations that are charged.
okay. So invocations as such, like suppose I'm triggering it from certain event, so I have the trigger condition, so that if the trigger condition satisfies, it will incur the cost. But using that Twitter connector will not incur the cost, right?
Yes, it won't incur unless it's a paid service.
Okay, okay,
If
okay,
it's a cognitive service again, so like what will happen is to calls, whatever it is going for the cognitive service will get charged, as well as for the invocations also you'll get charged.
okay.
Okay. Any other questions?
Yes, Abhishek, I had one. Actually, it's more like, while normally when we convert an entire application to, to work in a serverless architecture, we need to refactor it most of the time. So
Hmm.
there's this one concern that I had. It's moreover like, normally we tend to reduce code duplication throughout, throughout our code base in an entire architecture. But the thing is, by inherent nature, Azure functions, have everything. You want to write all the business inside the function itself. You don't want to code across multiple scripts and have a lot of lines inside of it, lot of business inside of it.
Okay.
So, so if there are three or four, functions which use a common core logic, so how
Okay.
to handle that? Because I cannot, be calling an HTTP call. I cannot be making an HTTP request every time. If I build a client every time, I call that. That buffer time would be around 5 or 6 seconds. If it is a long running business process, then it can take around 1 minute or 2 minutes or 3 minutes, depending upon the availability of the other function, or as a latency, or some other reasons. So at the time, I have a risk of being the full Azure function being timed out. So how do I mitigate these risks?
Okay. So you need to first like figure out which are your processing functions and your utility functions. Okay. And your utility function tasks, again, you need to break it up into smaller number of functions. So you can have a box having like you can have a couple of utility functions that will be calling each other and would be performing their activities in that time frame. So that is how you need to do it actually.
And in case one of the tasks fails, it is unable to process that, how do we actually make sure that that process is not missed? Like before, like suppose we have an order management system. Before
Okay.
confirming an order to the client, giving them a receipt, we should ensure that we got the payment from them. Once we got the payment, then only we can proceed further.
Hmm.
This thing can be achieved with durable function. You can orchestrate the thing. But what if we were just using Azure functions and had a situation like this, we are in which we are dependent on other functions to execute first. Like there are multiple modules, and one module after one another module, we are processing it by the help of multiple queues, which acts as a bridge between those modules. And suppose one of them is dequeued and it didn't execute, and we didn't uh, get paid, but that and we don't know that whether the customer doesn't know whether he'll be getting the product or not. So, how do we handle that?
Yep. So for that, you need to use circuit breaker pattern. So whenever you see that, you immediately stop the processing there whenever there is a glitch. Okay. So or else and also like at the same time, suppose a particular function is failing, that inside that function, try to have a logic. So if that function fails, it should not we should not be losing that item that has been dequeued. It should be pushed back to a dead letter queue and queue to the dead letter queue so that it can go for a retry. You're
Okay,
getting me?
that answers most of the thing. There's one more thing that I wanted to ask. If it is failing, if a particular function is failing multiple times, how do we troubleshoot that? It's like, is there a way in which, we can simulate the same inside our tooling environment and check, debug through it and check what, because of what particular reason it is failing out?
So yes, you can debug it. So what you need to do is it will depend on the logging mechanism you are enabling actually. So more the loggers you have in your application, the more the information you have, that will help you in debugging, right? So unfortunately, you can't put a breakpoint and check it there, like we have it development environment.
No,
Yep.
no, Abhishek, we can actually now the new latest Azure function is giving us those things in
Okay.
Visual Studio.
But
So you have to deploy, you have to publish it as a debugger, as a debug mode. After
okay.
that, we can actually remotely debug it. I have actually gone through it. So it will take little bit more time, but it will work.
Then it's a good time actually. This will help your thing maybe like you can try to simulate that environment. You can read through the logs and see the steps that has been performed. You can attach a debugger and you can get going. Thanks, huh? Thanks for this response actually.
Yes, no issues.
It's really a new thing for all of us, and definitely it will be definitely handy for us in our projects.
Yes, in production scenario, it's very handy. Yeah.
Yep.
Thank you, Anshuman. Thank you, Abhishek, for the answers. It was really helpful.
Any other questions?
I think, Abhishek, we can go ahead with the quiz.
Okay. Okay. Before we get into the quiz, so who was that who responded that answer? Anshuman, right?
Yes.
Can you call out your full name? Oh, I think I can see it here. So
Anshuman
maybe
Dixit.
okay, Anshuman Dixit. Okay, Anshuman. So what you do, right? Like a round of applause for him virtually out here, and you win a book because you have really given a new. You have bring in a new thing to the forum.
Oh, thank you. Thanks. Yeah.
Okay, but you need to fill in this details so that uh, Ashirvad will be able to, or I'll be able to reach out to you for your address and other details. Okay, let me open the
Okay.
form and give you the link. So, guys, your time starts now as soon as I'm pinging the link, and it ends when we are ending the session today. I think a lot of folks have left.
They are missing out on the book.
Okay. Maybe.
It's actually a good book, guys. Those who left sooner, they missed out. I have the book. I'm on the final chapter yet, and I must admit that Abhishek had, prepared it very well. The content is well curated.
Okay, cool. Thanks, huh? Thanks for this good words. Okay.
It was an honest feedback, Abhishek. I wanted to write and review on that, but I was caught up with things. I was unable to do it. I'll do it sometime later this week.
Yeah, sure. Okay. So you start answering the questions, then we will close the session and we'll communicate the winner. And already we have a winner, Anshuman.
Thank you.
we'll have three winners, and I think like so many, we have three parties, so all of you will get a book. But attempt the quiz so that I have your responses and I know your contact, how to contact you.
Abhishek, should I give the quiz? I already have your book. I'll have another copy.
Yeah, that's fine. You can give it to your friend.
Sure, thanks.
Okay, I'm stopping the screen share.
So Abhishek, you'd be announcing the winners now?
We'll send it in mail, na, Ashirwad.
Okay, perfect. That would be great.
Because,
That
like
would be
all of us are getting a book, like that's what I'm calling it out. So fill in your responses. I think we have a way. I thought of three books. We have, I think we have around 5 participants. All of us, I can arrange a book.
that would be great.
Yep.
Okay, guys, thank you for joining in, and thank you, Abhishek, for having for giving us the time to join in and sharing all your information. It was really informative, and I hope all the people who joined the talk actually enjoyed it and found it really resourceful. And we'd love to have you on board for our upcoming sessions in the coming year. And yes, guys, we'll be posting this in our YouTube channel. I'll be sharing the post in our LinkedIn page. This where all the official communication actually happens. So, in case some of you are actually interested to host a talk on any of the serverless offerings or serverless technology, whether it is in Azure, GCP, IBM, or anything, anything, just reach out and probably we can set up a call and host a talk. Thank you, everyone. Abhishek, do you have anything to add up?
I'm good. Thanks for being in the session, and I hope that you liked it and it will be useful while taking design decisions and all. Feel free to connect with me on LinkedIn, so we'll be in touch, and definitely looking forward to the next sessions from Ashirwad. So it's a wonderful community. Let's keep pumping this community forward.
Thank you, Abhishek. Thank you, everyone, for joining in on a weekend. Have a good day. Stay safe. Take care. Happy New Year and Happy Christmas in advance.
Thank you. Thank you.
Thanks,
Thank
Abhishek.
you.
Thanks, Ashirwad.
Thanks, Abhishek. Thanks, Asirvad.
Thank
Thanks.
you.
Thanks all.
Thanks.
Thank you.